Welcome, parents. The past 18 months have been hard on Texas students and families. Many students are struggling with on-grade level math content due to pandemic-induced gaps from prior grades. This struggle can be stressful for students and their families. Today's video will explain how you can support your students at home with math, even if you're not a so-called math person. We'll start big picture with thinking about what you need to know about effective math instruction, then narrow it down to step-by-step instructions on accessing resources that can support you at home. We know that math builds in complexity over time. Students best learn math when they begin in the concrete, which means that they work with objects that they can touch and move around, as you can see in the first image. In their classroom, students might work with cubes, tiles, or fraction bars, but at home, things like crackers, buttons, coins, or other small objects can work just as well. Next, students progress to representational work on the same concept. You can see in the second image that this means students are ready to draw the real objects. Finally, students can engage with more abstract math like the third image, which is the equations that you might find yourself most familiar. Only after practice with moving objects around and representing them through drawings are students ready to understand these abstract symbols. Many times when you're helping your child, it's a homework worksheet that focuses on the abstract when challenges arise. When students are struggling to understand a concept, you can and should move back to the continuum to intervene, moving back to the concrete or representational to help build conceptual understanding from the abstract. The good news is that high-quality materials are already built around this approach and can provide a great support to you and your family. High-quality instructional materials introduce concepts concretely and then evolve to abstract. Let's walk through this progression with a simple division problem. Annie had 6 cookies to share between herself and 2 friends. So how many cookies will they each get? Start with the concrete. Use 6 cubes or any other object to represent the cookies. Set out 3 pieces of paper to represent Annie and her 2 friends. Then deal out the cubes one at a time until they're all gone. Count how many each friend got. Next, represent the problem on paper by drawing 6 circles to represent the cookies and creating equal groups for each friend. Finally, use numbers and symbols to represent the problem using the equation 6 divided by 3 equals 2. Many times children get confused when they get to the abstract representation of numbers and symbols, so going back to representational or concrete will help them build their understanding. This process of developing mathematical understanding, from concrete to representational to abstract, is a big picture, long-term process. Your child might have a different level of understanding for different mathematical concepts, which is why using high-quality instructional materials at school and even at home can help continue to build and strengthen their understanding. A second component of effective math instruction is balancing conceptual and procedural understanding. Students can and should be developing their conceptual understanding alongside their learning of common procedures and algorithms. Take this problem, for example. There are many ways to solve. You could use the traditional algorithm of stacking the numbers, borrowing, and subtracting to solve. And what we mean by the traditional algorithm is the most common strategy that most of us were taught when we were learning to add and subtract. Although this process works for every subtraction problem, it's not always the most efficient method to solve. You will get the correct answer, but it's a lot of work, and there are many places for students and adults to make a mistake. Subtracting across zeros with this traditional method of solving makes the problem more challenging than it needs to be. Many of you probably instantly knew the answer to this problem when we presented it 2 slides ago. Not because you wrote it down, borrowed, or subtracted, but because you have a strong conceptual understanding of numbers. We want students to look at problems, think about what it's asking, the numbers, and select the most accurate and efficient strategy. In this case, 1,999 and 2,000 are 1 away from each other on the number line, so the difference between these 2 numbers is 1. This is a much quicker way to get to the answer in this case and leverages strong number sense for accurate and efficient problem solving. The past year and a half has included many disruptions for student learning. Math is sequential, meaning there are many skills that must be built before you're ready for the next skill. For example, to do long division, students must be fluent in place value, multiplication and division facts, and subtraction. When we think about supporting our students with unfinished learning from the pandemic in math, there are 2 main strategies that schools are leveraging. The first is a traditional approach of remediation, or reteaching the content from a previous grade level. The second is acceleration, which is the strategy of incorporating prior grade level content throughout the year and then quickly getting back to on grade level work. This kind of instruction often has students constantly looking back and focusing on content that's not long applicable to grade level concepts, and as a result, students often never catch up. This form of instruction is what cognitive researchers call block or mass practice. It's the concept that implies that new learning cannot happen until all old learning is mastered. While this might feel intuitively right, cognitive researchers have helped to illuminate the fallacy in this thinking. While these types of learning practices may lead to short-term results, they don't lead to long-term sustained learning that we know students need. Recent research has highlighted this finding. Therefore, it's not an effective learning strategy. Now let's look at what accelerated instruction looks like in contrast. For acceleration-minded educators, their approach to instruction is very different. Educators review the grade level content and identify the content from prior grades that students must understand to access that grade level content. Then, educators administer a pre-test to diagnose a student's current understanding. Finally, acceleration-minded educators recognize that learning within context is critical. So while the educator recognizes important prior grade concepts, the teacher is not blocking those concepts en masse at the beginning of the school year or semester. Rather, the educator is choosing proximity and only highlighting those prior year concepts when they're most applicable to the current grade level content. Keep in mind that this illustration is conceptual. In practice, there are nuanced differences in how we approach acceleration in each content area, given the science of how students learn to mathematize. The most significant difference, noticeably, being that students who significantly lack competency in foundational numeracy skills may still require explicit, structured math intervention that may be front-loaded, rather than presented in the context of new grade-level learning due to the science of how students learn math. Which may sound like remediation at first, but it's better categorized as targeted intervention when you consider that this sort of intervention should always be provided in addition to receiving access to core math instruction. It no longer fits the definition of remediation, where students are prevented from accessing grade-level learning until they've mastered prerequisite skills. Using a third-grade math example, the remediation approach would be to front-load second-grade skills like addition and subtraction prior to engaging in third-grade content. However, an acceleration approach integrates the prerequisite skills that are most essential to the third-grade standard as just-in-time support throughout. For instance, practicing grouping using images as it connects with division. But the big idea here is that when all students need some sort of instruction in order to access new content, they get it just in time, as it applies to that new content. Instructional materials must be designed to provide this kind of instruction. The key to catching up in math is continued access to grade-level material with support in the previous grade-level content right when they need it through high-quality instructional materials. TEKS' Home Learning provides high-quality instructional materials that can be used at home or at school. These materials have been intentionally designed to support learning acceleration and provide built-in supports to help students find success on grade-level content. They're grounded in the process of concrete to representational to abstract that we kicked off the presentation talking about, as well as focused on balance of developing procedural fluency alongside conceptual understanding. We have 2 K-5 math products to introduce to you today. As we're going to walk you through the process to quickly and easily gain free access, we might as well highlight some of the ways you can use them at home. Depending on what you're looking for and what support you can provide, one of these resources may be a better fit for you. First, we'll discuss Eureka Math TEKS Edition, which is a core math program that provides daily lessons, videos, assessments, practice pages, and full TEKS coverage at each grade level. While this is a full package for teachers and schools, it has pieces that can really support you at home with your child. Next, we'll discuss ST Math, which is a digital, game-based program that builds students' conceptual understanding through largely independent work. With ST Math, you can get students set up and running instantly, and this program is incredibly easy to use at home. First, let's talk about Eureka Math TEKS Edition. This product includes several resources that are particularly helpful to families, including family tip sheets which explain key concepts, provide sample problems, and illustrate ways to support with the mathematics and vocabulary by topic. In addition, there are videos, lessons, and practice activities for every lesson. While supporting your child may look like conversations with their teacher to find out where they are and what they're working on, to help your kid at home, you don't have to know math. To see a concept your child is struggling with, you can go pull practice and videos from Eureka Math TEKS Edition. You'll also have access to all content grades, kindergarten through 5th, so you could pull resources from another grade level as needed. The daily videos are especially helpful as they're created by a teacher, are student-facing, and teach your child the concept for the daily lesson. These are a great way for you and your child to learn together and then work on a practice page on the same concept. The video teacher will even make recommendations of which problems on the practice page to focus on. When selecting content to work on, consider what your child is learning in school that's been challenging for them and what may be helpful to have additional learning and practice on at home. Here's how you sign up to use it at home. These materials are comprehensive and include all resources a teacher would need for a year's worth of grade-level math instruction, but there are helpful components that you may want to utilize at home. The first step to gaining access to Eureka Math TEKS Edition is to fill out a quick request form for individual access. Educators can submit a request through the district access, but all Texas parents are encouraged to access materials through this individual access request. Start by entering your first name, last name, and a personal email. Select parent/family for role and homeschool for both district and school. Check the 3 boxes at the bottom to confirm you're a Texas resident, over the age of 13, and agree to the terms of use and privacy policy. Then press the Submit button. Once you submit the form, you'll get an instant confirmation email containing a link to the login and access materials, as well as a demo account that can be used to access all of the materials while your individual account is being created. Enter the email and password for the demo account and press Login. Once logged in, you'll have the option to select Eureka Math TEKS resources, as well as the grade level. Within each grade level, there are daily lesson plans, videos, family resources, practice pages, and much more. The second math product included in the Texas Home Learning suite of resources is ST Math. ST Math is a K-5 visual instructional program that leverages the brain's innate spatial temporal reasoning ability to solve mathematical problems. Students work through puzzles and activities independently and at their own pace. This approach allows students to build their mathematical understanding regardless of their current instructional level. Here's a quick look at the type of learning your child will do in ST Math. In this game, Pushbox, students are challenged to put together 2 groups of blocks and identify how many there will be when combined. Watch how the game works. Getting started with ST Math is quick and easy. If your child already uses ST Math at school, they can log in at home using the same credentials. If your child's school does not use ST Math, you can quickly sign them up and have your child online and practicing within 15 minutes. First, fill out a quick request form, similar to the Eureka Math TEKS form. You'll be instantly emailed a link to create an account. Once you create an account, you'll receive a second email to confirm your account and sign in. When you sign in as a parent, create an account for your student with their name and current grade level. There's a very helpful Getting Started video in the top banner of the parent dashboard to walk you through exactly how to get your child started. Give your child their login information, a computer or tablet with the internet, and watch Gigi the Penguin lead them through fun, rigorous mathematical problem solving. To obtain the best results, work towards meeting the target usage minutes, which are 60 minutes a week in kindergarten and first grade, which equates to about 10 minutes per day, and 90 minutes in second through 5th grades, which is about 15 minutes per day. As your child makes progress, you'll be able to monitor using your parent dashboard. You can set goals, offer support, and celebrate progress as they go. You also have many options to customize through your parent portal. You can change your child's grade level, assign additional content, or rearrange the order of lessons. There are many ways to support your child in his or her mathematics education in partnership with your school. Your school can further help you understand what materials they're using to support your student. If you know there are particular math concepts that your child is learning in school and needs more support with, you can use practice and videos from Eureka Math TEKS Edition to support their understanding of specific math concepts. You can also directly sign up for ST Math for easy, fast access to independent math practice for your student. This is a quick and easy resource and is one you can start today. Your support will mean a lot to your child's mathematics education. Thanks for your partnership.